everyone. Thank you for joining us for Skype a Scientist Live today. Before we get started, I wanted to address some stuff that you can check out this week. So as you know, there's been a lot of turmoil happening in the country over the treatment of Black people in our country. And so there's a group of Black scientists that are sharing their experiences in nature over this week. It's really wonderful, uplifting, and they're putting out great stuff. So if you want to check that out, we totally recommend that you do. You can do that by following the hashtag Black Birders Week. Birder, like people who like to check out birds. You can also check out the Instagram and Twitter profile, Black AF in STEM. They're a whole group of people that are just the best. One of the leaders of that group is one of our board members, Karina Newsom, who puts out some of the most uplifting, wonderful stuff that's available on Science Twitter and Instagram. So definitely check that out. We are canceling our trivia for this Thursday for anybody who attends that because it's overlapping with a Q&A they're doing at 7:30 p.m. On Thursday. So if you want, you can check that out as well. We'd recommend that instead of donating to us this week, you pick another group. There's a GoFundMe all about getting free binoculars to Black birders that are coming up in the field. And also you can donate to bail funds as well if you're able. So we can hang tight with a week without donations. If you can donate to them, we totally support that. We are very supportive of all of the protesting happening in our country. So, but we're not talking about birds today, we're talking about space. So I think that's all I have to say housekeeping wise. Tomorrow, we're gonna be talking about wildlife forensics. On Wednesday, we're talking about how people perceive wildlife. And then Friday, we're talking about all about paleontology, specifically all around Triceratops, because that's what the scientists we're talking to Friday knows about. Other things happening this whole 3-week period from today until the 19th, we're exclusively featuring queer scientists on our Instagram, on our live streams, when next week's trivia happens, my co-host is as well. And so for the next 3-week period. So that's what's up with Skype a Scientist, but I'll stop talking about housekeeping and let's just get into the science of space. So today we have Erin Eldridge joining us. And so Erin, if you want to introduce yourself, say who you are, what you do, why you like it, and then we already have a lot of questions already.
Yeah, I saw some of those rolling in, but yes, hi, I'm Erin Eldridge. I worked for Barrios Technology for almost 10 years in Houston as a subcontractor to NASA Johnson Space Center. As it just happens, I worked closely with the commercial crew teams. So I worked with a lot of the people who worked directly on the Dragon mission that just happened. I met several of the astronauts, though not any of the ones who flew this time. And the tool that I use to help astronauts on the space station monitor incoming visiting vehicles was used for that flight. I got to see it because my friend at Mission Control is also working from home, and so they sent me the video that they were seeing to monitor it because they knew I'd want to see it. But yeah, now I'm an independent space consultant, and I've just always loved space. It's really cool. It's one of those things where there's a lot of hard work to do and the problems aren't solved yet, and I like solving problems. So
awesome. So okay, I admittedly, I'm a squid biologist. I don't know much about space. I know as much as your average Discovery Channel watcher does. So okay, we have a shuttle that goes up to space. What part of that whole process did you or are you working on exactly?
The bit that I worked on is all about when the vehicle, like the Dragon spacecraft that launched this past weekend, arrives at the space station. The dynamics between two vehicles that are in orbit, both of them are following in circles around the Earth. And so it's not necessarily intuitive to a human who hasn't trained, what they will do. And even people who have trained, it's much more useful for a computer to just work out, okay, these are the physics. And if I do this, this is where I'm going to be in 45 minutes, which is half an orbit around the Earth. So the Windows application that I worked on just tells you that this is where this vehicle is going to be over the next 10 minutes, 40 minutes. This is what it's going to do. And that way, if it's going to do something scary, which didn't happen this time, thank goodness. But yeah, that's what the astronauts wanted to know. And so that's what we give them.
Awesome. Sounds good. So what exactly was the Dragon mission? Like, what was the purpose of this launch?
So this is the first crewed launch of the Dragon spacecraft. So it's their second test mission. The first one was last year I want to say it was the beginning of April or the beginning of March, and now I'm blanking on it. But what I remember most distinctly was that the flu was going around. I definitely had it during that. But this one is just the first, let's say, operational test. The purpose of the spacecraft is to get people and cargo to and from the International Space Station, and it did that this time. Last time it was just a cargo mission, and this time it's doing what it's supposed to and demonstrating that capability masterfully, I must say. So.
Awesome. That's really exciting. Let's see. Okay, one person just talks about the mission. So some of these questions may be totally out of your field of expertise, and so generally speaking, we always try to tell scientists, like, if you don't know, it's totally fine. Like, this is a no shame zone. And also, having people hear that scientists don't know is sometimes really heartening and makes us seem less intimidating. So
there's definitely a lot that I don't know. I admit it right now.
Yeah, I'm a squid biologist. There's still so much I don't know about squid. Okay, so the first question is, why is there less gravity on Mars?
Because it's a smaller planet.
Fair enough.
Gravity comes from mass, and Mars has less mass than the Earth does.
Great, simple, so simple. That's wonderful. How many years have you been doing the job you're doing?
Oh gosh, I suppose my first real spacecraft experience started in 2006, and that was at university. I started getting paid for it in 2007, and I graduated into the Great Recession, so I started getting paid for it like steadily in about 2010.
Right. Yeah, I graduated right after that. So I just went to grad school instead.
I wasn't smart enough. I had a 2.62 when I graduated from university.
Yeah, I feel your pain. Gavin would like to know, why did it take so long for the United States to make Dragon?
That's probably one of those things where I should answer, I don't know. There were a lot of competing efforts for various things. I guess it depends on when you start counting from. The timelines, if you look at when SpaceX started making the Cargo Dragon spacecraft to when they deployed that, and then from when they started making the crew version of the Dragon spacecraft, which, depending on how you think about it, it involves a lot of new systems. And I should probably say now, I have never worked for SpaceX. I've worked, I have had teleconferences or met people from SpaceX. I've talked with them, and the teams that I worked closely with at NASA, which I was also not a NASA employee, I was a contractor.
Right.
We supervised or did requirements verification for SpaceX sometimes. We also did some of that for Boeing. We did some of that for Sierra Nevada for Dream Chaser. And I also did some of that for NASA's Orion. I lost my train of thought. Anyway, the timelines there are roughly standard, maybe a little bit faster than a usual aerospace vehicle's development, about 10 years. So if you look back at Apollo or Shuttle, those also took about that long.
Sounds good. So before we were using those, like, what I think of as like classic looking space shuttles that are like kind of triangle shaped, like the Discovery and the Enterprise and the Challenger, and that like series. But then we stopped using them. We put them out of commission, and now we're switching to this Dragon. Is that correct?
Um, sort of. So NASA did switch from capsules to winged vehicles, essentially, with Space Shuttle.
Mhm.
And there was a whole effort around that time to continue on with that. There were several programs, the X-38 Crew Return Vehicle, the X-33 Venture Star, all of them had, if not wings, then what are called lifting bodies, where the entire spacecraft also generates aerodynamic lift, just down to a function of shape. The Let's see here. All of that comes at some cost. Basically, the ability to have wings or wing-like features gives you flexibility when you're flying in air. It doesn't really do anything for you when you're in space. And so that gives you, let's say, more options when you're landing. As you're
Oh,
coming back from space, that gives you more landing sites. And so, you're more flexible with weather, stuff like that.
right.
But if all you're doing is running cargo to and from a space station in low Earth orbit, then capsules are more efficient. Um, and so that's kind of, I don't want to say what we're falling back to, because it's not like we're taking a step back. These are still advanced vehicles, and they actually, in some ways, have more capabilities than Space Shuttle did.
Uh-huh.
Um, but it's one of those things. Having wings or not is an engineering trade-off. Having wings gives you some things. Not having wings gives you, you know, you can use that mass that would have been wings for cargo or people or stuff like that.
Right. And so over the last like 10 years, let's say, we've watched online a lot of videos of these like torpedo kind of shaped objects trying to land on a boat. And so it was a lot of the, like, you can obviously tell that I like don't know much about space. I'm like just getting it from society. But like,
That's a
so
good example, or a
the
good
big
description
thing
of
they
it.
were like testing was uh instead of landing like an airplane, like landing a torpedo up and down. And that was like the big innovation that we have with this new Dragon, among a lot of other things, obviously.
That's I would say that it is one of the secret sauces that SpaceX has. Coming out of Space Shuttle, when I was in school for aerospace engineering, there was a lot of dismissal of one of the core concepts of Space Shuttle, which was the idea of reusing spacecraft to make them cheaper. It had turned out that refurbishing Space Shuttle, which was covered in things like ceramic tiles that fell off, needed to be replaced, needed to be checked very thoroughly, and other complex systems that I'm not even going to get into. Um, it took a lot of time, it took a lot of money, and so coming out of that, when you look at the programs that NASA stood up in the early 2000s, Constellation, which then became SLS, and I'm glossing over a lot in the middle there, but there's definitely heritage between that Constellation program and SLS, which is currently in development, along with the Orion space capsule that's going to be on top of it. Um, NASA had basically decided, okay, it's better for us to do single-use spacecraft like we were doing in Apollo. Ultimately, that's going to be cheaper for us. And SpaceX wanted to do reuse. And so they focused on doing things like recovering those first stages by vertically landing them, and also reusing the Dragon capsules, and they talked about second stage reuse as well. So the first stage of the Falcon 9 booster is what lands on the barges or at the pads at Cape Kennedy, or Kennedy Space Center. Let's say I'm using like ancient names for it because for no good reason, but. The second stage, which drives the Dragon into orbit, because of how much energy it has, and because it's essentially just a rocket engine and fuel tanks, it has no ability to be reused. It gets put into a disposal orbit and then eventually falls into the ocean, I believe, in the Pacific. But
How do
so
you
they
control where a thing falls out of orbit?
timing.
Okay.
You wait for the Earth to rotate into the right place, essentially, and make sure that you're coming in, or that what you want to dispose is coming in steep enough that it doesn't skip off the atmosphere and do something unpredictable.
Right. Sounds good. So there's a lot of like stuff in space, right? Like what we call space junk. Like how much of a problem is that?
Um, that's pretty close to the edge of my knowledge.
Oh, that's okay.
What I could say is, on the one hand, both the sky and space are big. That the addition of that third dimension gives you a lot of volume, a lot of ability to have things go around other things. Um, that said, the the problems with space junk are real. They're not like you saw if you watched the movie Wall-E, where there's literally a spherical shell of spacecraft that you have to push through. Space is still very much empty, even in low Earth orbit. But there's enough, particularly small things, um, loose pieces of explosive bolts or flecks of paint in orbit, uh, and they pose risks to other things in orbit because all orbits are very fast. To be able to be continuously falling around the Earth but not hit the Earth, you have to be going around 25,000 miles per hour at least. And so that's fine if, like with the Dragon and the ISS, they're going 25,000 miles per hour in the same direction, because then relative to each other, they're not moving. And if
Right.
you watch the rendezvous, they move very slowly relative to each other. But if they're crossing, there's 25,000 miles per hour in one direction and then 25,000 miles per hour, 30 degrees in another direction is never going to be zero. It's
Right.
always going to be thousands of miles per hour, which ends up being a lot of potential energy in a collision.
Right.
And that that and the fact that when two things hit in space, they tend to become more than two things are the problems of orbital debris. And what we fear is what's called Kessler Syndrome, where you get an exponential growth in orbital debris because two things hit and then there's more things to hit and then they continually generate more debris just by the number of collisions happening in orbit. And eventually, because of all those collisions happening and because when these things collide, they move in not random directions, but more than the directions that the original debris had.
Right.
You can imagine it's sort of like a shotgun blast. Eventually, if all of that stuff is happening in low Earth orbit, you can't get beyond it safely. And so then space isn't useful for things like communication satellites or weather satellites or GPS.
Yeah. It just now, 31 years after being alive, occurred to me that everything's not going in the same direction. That like things are going in all. That's wild. So
Right.
okay, if you're in the ISS, how the heck do you prevent getting hit by random stuff?
There's two main parts of that. The first is knowing where the random stuff is.
Uh-huh.
And essentially, I'm going to say this is part of a larger Cold War effort to know where things are in space because we were scared of the Russians as the United States at the time. We have amazingly powerful ground radars that can see things like, let's say, BBs, those size objects, and track them in space and keep a database of those. And luckily, a thing like a BB doesn't move around a lot. Um, it follows a pretty predictable trajectory, though when you're in low Earth orbit at something like the altitude that the ISS is at, which is around 400 kilometers up from the ground, there is still enough atmosphere that it doesn't just move in a circle anymore. It is in a decaying orbit of some sort. Exactly what that orbit is, it's very hard to predict because the upper levels of the atmosphere are so thin that they react to very subtle changes in the solar weather, essentially. So the number of sunspots changes the density of the atmosphere up there.
Whoa.
So the weather at that altitude is much more difficult to predict than the weather in Houston, which right now you predict rain. You just predict rain. But unfortunately, as much as those things can get moved around by the little bit of air that's there, they're also so small versus how massive they are that they don't decay quickly. Something that, for example, if the International Space Station just rotated 90 degrees instead of being, essentially pointy end first, it was wide end first, it would come down relatively quickly, I think in the span of months, just from the atmosphere up there. Those BBs don't come down in months, they come down in years probably. So they're all still problems. And I've lost what the original question was.
We were talking just about like orbits and how to not get hit by stuff.
How to not get hit by it. Okay, right, the first part was knowing where those are.
Where stuff
The
is.
second part is that the International Space Station, once you know where the thing is and that it's going to get close to you, they move the station. They use thrusters, they change the orbit, and they go away from where the potential collision is.
Right. I didn't even know that they had the power to move the thing. So,
yes.
Okay, so you need to have a certain amount of velocity to keep like in the distance from the Earth's crust effectively that you are, or the ocean or whatever. And so sometimes they need to like put the thrusters on to like get a little, if they're like slowly going down, you gotta like put it into high gear to go a little bit back up. Is that how that works?
Yeah, to maintain the orbit that they want, they do what's called a reboost. And sometimes a vehicle like the Russian Progress, particularly the Space Shuttle used to, lends their thrusters to the space station, but also the Russian segment of the space station, which is essentially the back of it. Most everything behind the massive beam that holds the solar panels on the space station, which I think most people will be familiar with. Most everything behind that is Russian, and the front of the station is American and European and Japanese modules.
Cool.
But the Russian part has thrusters and part of the control.
Very cool. Awesome. So to change gears a little bit, Adeline would like to know, if I want to work in mission control, what do I need to know? What do I need to do?
No science stuff is about as specific as I can get. There's a lot of different disciplines in mission control. What to do, I think, is, this isn't quite current maybe, especially there is a recent boom in aerospace hiring, so NASA's hiring practices might be changing, but for many years, NASA's primary hiring pool was their interns. So getting an internship at NASA, particularly through a university, is the way to go if you want to work directly for NASA. Not everybody in mission control is a NASA employee. I forget who the primary contractor is who does other stuff there. I was only ever there in what's called the mission evaluation room, which is way, way, way in the back. But and I only supported a handful of flights because the thing that I do was only used for a handful. But yeah, I think that's as close to an answer as I can get.
Sounds good. Thanks. The next question is from Jacob. When do you think the first human will go to Mars?
That's such an interesting question. If you asked anyone within the past 30 or 40 years, I think all of their answers would have been wrong. My answer is probably going to be wrong too. There's like a classic canned response for fusion power, which is that it's going to be in 30 years. And it's felt the same way for Mars for a long time. I do feel like it's getting closer every time SpaceX blows up something in Boca Chica. But I don't know. It's going to be such a gargantuan effort to put people on Mars and have them live there that things, the changes in other parts of the system of the world, shifts in funding priority for NASA, of course. But if Elon Musk decides he's going to do something else, that would set Mars efforts back a lot too. Now,
Right.
it's up to people committing to it for probably 20 years of work to launch the mission at least.
Right.
And so I don't know. 30 years is less than 30 years is my hope, I guess. I want to see it happen, but I
Sounds
don't know.
right. Well, fingers crossed. David would like to know, what are some of your favorite space and or rocketry movies, books, or anything like that?
Um, I'm trying to think of what the last space movie I saw was. I did enjoy Gravity. There's, I think the YouTube video that Chris Hadfield did for Wired about his criticisms of that is entirely appropriate. But that's a fun one. Um, Mission to Mars, I remember fondly. Apollo 13, very good movie. Um, Wally, I enjoy a lot, even if you might not call it hard science fiction. Uh, but yeah, those are the ones that come to mind.
Awesome. Sounds good. Did you see that Netflix just released Space Force with Steve Carell?
I did. I've watched probably the first half of that season. I
Oh,
watched a lot of it while I was also watching the feed from Mission Control, just because you the Mission Control stuff is exciting in short bursts and then routine for
and yeah.
several hours. So
It's
it's
the
a good
same
thing
with
to have
deep
a
sea exploration. Yeah, I'll have it
yeah.
going in the background, and then when you get an animal, it's like, all right, and then very nothing for quite a while. Um, all right, next question. How do meteors come to Earth?
Um, Gravity is the short answer. Depending on what the the chunk of rock or whatnot that ends up hitting the atmosphere is. I know for certain that meteor showers like the Leonids, and I'm struggling to remember the other ones. Constellation named with the suffix ids.
Perseid,
Uh,
I think, is one. Yeah.
Perseids, very good. Yeah, yeah. But those tend to be debris from comets. Um, which just leave tiny chunks of themselves behind. But like we were talking about orbits intersecting, it's the same with orbits around the sun. Not everything is in neat circles all going the same direction. So as long as something was going in a different direction and comes close enough to the Earth, it'll graze the atmosphere. And catch on fire isn't quite the right term. A lot of the fireball, which is what meteor means, is fireball, is air compressing in front of and around that object because it's going so fast, and the air just has to try to get out of the way somehow. Um, it glows. It just gets that hot that it glows, and that's what results in a meteor. You get a meteorite if it actually lands on the ground. And it's a meteoroid, I believe, beforehand. That's, I guess, a meteor candidate. And an asteroid if somebody saw it from the ground and was able to identify it, I think.
Cool. That's awesome. I had no idea about why the light shows up. That's really, really cool.
Yeah.
The next question is, what does it take to be an astronaut?
A lot of luck,
Yeah.
among other things. I think famously one of the current astronaut class, and I'm going to feel really bad if I get the name wrong, I believe it's Dr. Johnny Kim, is not only an ex-Navy SEAL, but has multiple doctorates,
Oh
and
my
I
God.
believe is younger than I am. I'm 35. I don't remember this astronaut's age, but um, there is a lot of demand to be an astronaut. The number of applications that NASA gets is enormous, and so many advanced degrees. Persistence is one of the other things I've heard. When you live in Houston and work with NASA, a lot of the people who work at NASA in other jobs also want to be an astronaut because space is cool. I want to be an astronaut. I haven't actually applied yet, but most people as far as I'm aware, apply 4 or 5 times before they get accepted as an astronaut candidate. So persistence is a big thing. And aside from that, there certainly seems to be a preference for people who grew up around Houston and who have connections somehow. So, if you happen to take advantage of that, that's
So it's
that's
a
the
lot of
answer
luck,
that I've got.
basically. A lot of luck and being totally amazing at
A
the
lot of luck,
same
yeah.
time. Oh, good. Okay. The next question is, when did you know that you wanted a career in space?
Um, when I first went to college in 2003, the first what became Ansari X Prize, I think it was just called X Prize at the time, for putting a spacecraft into orbit twice in 2 weeks was going on. And I believe in 2004 or early 2005, Burt Rutan and Scaled Composites won the prize, which was maybe $100 million. It's either 10 million or 100 million. Some number that's both enormous but doesn't cover the costs at all of doing what the work that you need to win the prize. And they won that with Spaceship One, and then he was doing a speaking tour to universities about the work that it took. And so I was living in Central Texas at the time. My dad said, "Hey, let's go when Burt Rutan comes to the University of Texas." Okay, we go, and we went to, I think, the public session, and then we snuck into the one that was for the grad students of the university. And somebody asked a question, which is very specific to Spaceship One, but it was about why doesn't the landing gear on Spaceship One retract? And the answer, which I heard my dad say as I thought it, and before Mr. Rutan responded, was it didn't need to. For that mission, all it needed to do was get launched and then come down, and then the landing gear had to open so it could land. It didn't
Right.
need to come back up. It was already on the ground, and they would, people would do that by hand. Um, and in that moment, I realized that this was a doable job. I had idolized it before, as these people are much smarter than me. There's no way I could do that. I was working to be a pilot at the time, and also had thought about being a programmer, but didn't think I was good enough to do that either. And then once I had that realization, I took the courses at the University of Texas and did very badly there, but ended up being a programmer for NASA. So it was that realization that, hey, this is a hard job, but it is doable. That's what really got me into it.
That's awesome. All right. The next question is, do you have fun every day? And do you think there are any problems with exploring space?
Those seemed like two very unrelated questions.
Yeah.
Do I have fun every day? No, I try to, but no. I actually have depression, which makes it difficult. So,
Yeah.
but I figure you may as well throw it out there. I'm definitely not the only person working for NASA who has that. I'm not
Yeah.
the only pilot who has that either. So
Or
those are,
academic in literally any field. It's
yeah,
common among all scientists. Yeah.
yeah. So that's something that people should know, is that you can do these jobs even with crippling mental conditions. But what was the second part of the question?
Are there any problems with exploring space?
The fact that space wants to kill you. It's very empty. It's not cold. People misunderstand that. It's just very empty. But being void of air causes a lot of problems. It not only, you know, makes it hard to breathe in the most real of ways, but also exposes you to a lot of radiation from the sun. Your skin doesn't like that, especially if you have any other thing near you that does have air. The skin wants to go. There's a pressure differential, and the skin gets sucked toward the void instead, and it causes pressure bruising. Um, and yeah, the space is a very dangerous environment. which we also don't understand as well as the sea or the air. There's a lot of material problems with radiation that we're still learning about long term. Just as an example, every astronaut who's ever been in orbit, but more particularly people who've been beyond low Earth orbit, like the Apollo astronauts who went beyond the Van Allen magnetic belts, which protect us partially from radiation. Um, they report when they close their eyes, they can see radiation pass through them. You see flashes of light just from high energy particles striking the back of your eye. Um, so completely different experience, right?
Right.
It's one thing to know the statistics that even pilots, people who spend a lot of time at 30,000-ish feet have higher instances of cancer. They have more radiation exposure than people who spend most of their lives near the ground. It's that much worse for astronauts.
Right.
Just a very different environment.
Totally. What's the longest anyone has lived in space?
I believe it's around 2 years, and I forget who holds the record now. There was, I think, one of the Kelly twins had the record for a while, but I'm not sure if he's the current record holder.
Cool. Sounds good. That's a long time to be not on the ground. That's wild.
Yeah,
Um, the next question is, do you think that aliens exist?
I do. It's one of the other movies I should have mentioned was Contact with Jodie Foster. But I absolutely believe the sentiment that was expressed there, that it's a big universe. The numbers about how big the universe is are really difficult to comprehend. Um, I don't have names for them. It's 10 to a very large number. I think it's like 10 to the 80 atoms and 10 to the what 30 some odd galaxies. Uh, So I would be very surprised if we're unique in the universe as thinking beings. I, I don't think we're unique, honestly, on the Earth as thinking sentient beings. I think we just have trouble talking to some of them. But the one asterisk I want to put on all this is that, do I think that aliens have visited the Earth, especially recently? I don't think so. But we don't have compelling proof. Is there a chance? A small one, I think, but it's one of those things where space is really big. Getting from star to star would involve enormous amounts of energy and a lot of time. So I would think if people, and not necessarily human people, but if people had come, they would have stuck around. They would have made it very obvious because it's a big deal to do it.
Right. Awesome. What's your favorite part of your job?
Um, Honestly, the people. I have so much fun with the people that I've worked with. Um, One of the things I've missed the most about the quarantine during the pandemic is the terrible, terrible whiteboard art that we would do at work.
That's
We
awesome.
we would just make awful comics with horrible in jokes. But yeah, the people.
That's great. That's a great answer. So we try to keep these to 45 minutes and we're already approaching that. So we always like to ask folks the same two questions at the end of these sessions. And the
Okay.
first question is, what is something that you wish everyone in the world knew about your area of expertise? And the second is, what do you wish everyone in the world knew about literally anything? It can be as small or significant as you'd like.
Okay. Um, what do I wish people knew about my area of expertise? I guess I wish people understood how much space pays back. Um, it's it's a mercantile thing to say, I guess, or a mercenary thing to say, but it, the things that we do with space are worthwhile. Most of the examples people think they know, like Velcro wasn't invented for space. It was invented by a Frenchman, I want to say, in the 50s. But we do worthwhile research. We have, worthwhile applications. Again, weather satellites in particular, I think, are have saved so many lives that we can't even credit them for. But and the applications we found for the global positioning system are just amazing. It's enabled so much of the robotics revolution that we've had in the last 20 some odd years. Um, I wish people knew it was worthwhile. I think a lot of people think it's a money sink and worthless, and it's not. That even if it was a massive money sink, the money gets spent on Earth. Almost all of that money goes to people like me who, maybe I do get paid too much, but I spend all of it at the local restaurants. So
Right. We're back
it's
to the economy.
right. It's worthwhile for other people. And I guess the second thing, what do I wish people knew about anything? Statistics. I wish more folks knew just things like the Bayesian inference process, just the little things like how does a false positive rate or false negative rate impact anything? Because so much of what we should be relying on for decision making in the modern world ends up being some kind of statistical process. Um, and maybe another thing out of statistics I wish people knew is just coming to mind is that you cannot rank statistical groups. There's a lovely example of this done by a professor, Tadashi Tokieda, and there's a YouTube video, I believe it's called Winning Dice, that a channel called Numberphile did. But he showed that with that example that if you take dice and sort of change the faces, you can't say that one will necessarily beat every other die all the time. You can make it so that die A beats die B and die B beats die C, but A doesn't beat C, or there's no transitive property anymore there. Just it once you get into statistics, the normal rules of ranking things don't apply anymore. It
Right.
becomes much more complicated. I guess that's the upshot of the second thing I was trying to say.
Statistics is complicated, and it would be better if we
Yeah,
knew more about it. Yeah. Yeah.
right.
All scientists for sure should know more about statistics than we do, particularly in biology. I mean, some people are obviously great, but I'm not. So
Yeah.
anyway, that's great. Is there anything you'd like to plug before we wrap up?
Oh goodness. Honestly, I think the most worthwhile causes are the ones you were championing at the beginning of the video right now. I'm donating to local bail funds.
Same.
That feels like the thing that I can do right now with too much money I get paid for space work. But yeah, I actually want a link for the stuff that you mentioned earlier.
Yes. I can't give you a link in here because our chat
Right.
is disabled, but if any of you ask in the Q&A for a link, then I can type it to you. So if someone could do that, just say link, I can give you that. And where can we find you on social media?
Oh, it's probably a terrible idea, but I'm on Twitter at Chateau Erin. It's CHATEAU ERIN. And I've only got 200 followers for a reason. I mostly just retweet a couple of other accounts that I find interesting, and the stuff that I post on my own is not interesting. But if you
Well,
want
don't
to
sell
follow
yourself
me,
short. Awesome. Okay. So yeah, before thank you so much for taking the time to be with us today. I've learned so much about space, and uh, I don't know, that's amazing. We've done a lot of space sessions, but a lot of it has been like way, way, way out in space and not how we get there. So this session has been really unique and awesome. And
well,
we
thank
really
you.
appreciate the time that you're taking today. And Erin, thank you. Erin Fell, thank you so much for signing for us. I am right now
Well, thank you.
pulling up the Philly Bail Fund. That's the bail fund I've been donating to because we're located in Philadelphia. But they're, in general, things that you should be paying attention to this week, aside from all the protests and all of the really important stuff that's going on around that, is that there's a Blackbirder Week happening right now. You can look at the hashtag Blackbirder Week, or is it Blackbirders Week? Let me figure out whether it's plural or singular. It's on my Instagram. Birders Week with an S. Check that out. There's a lot of really cool stuff. Follow Black AF in STEM on Instagram and Twitter. And there's the bail fund in the answered section. Thank you all for coming today. Tomorrow we're going to be talking at 1 p.m. Eastern all about wildlife forensics. And we'll, of course, mention all of the things we mentioned today about the stuff going on in the country tomorrow as well, and give you some more links and stuff to do. If you are a white person, talk to your friends and family about what's going on in the country. A lot of times we really have to hold each other accountable. We shouldn't be relying on other people to tell us what to do. So do some reading. There's some really great books out there that can help us a lot, like So You Want to Talk About Race and How to Be Anti-Racist. These are both great books you can check out. And that's what we've got going on. We will see you all tomorrow. Thanks so much for joining us today. And thank you, Erin and Erin.
Thank you.
All right, bye-bye.
Bye.